Hi, this is Dr. JMR, JMR Chemistry. Today I'm going to explain important questions in chemical bonding. So here, today I'm going to explain multiple choice questions, that is more two or more correct options. Because in many competitive type of examinations, it will come one correct options. But here sometimes it will come two or more correct options. So it is very difficult, but even though you have to what you call expose like this type of questions. So now I'm going to explain the important questions which is present in chemical bonding. Our first question, identify the correct statement, whether it is a S, one or two or three or four of the following. We'll go through one by one question. That is, first one is aluminum has a tendency to lose three electrons. Yes, naturally. Suppose you take aluminum atomic number is 13. So here aluminum electronic configuration is 1s2, 2s2, 2p6, 3s1, 3s2 and 3p1. So valency shell contains 3 electrons. So naturally, it will become octet rule, means it is ready to donate 3 electrons. Aluminium minus 3 electrons, it will become a stable electronic configuration. So that is why plus 3 is more stable when compared to aluminium atom. So ion is more stable. Yes, this is right answer. So next, atom that gain electrons to become anion naturally. Suppose you take Cl, by gaining one electron, it will become what? Anion. That is Cl minus 1. Yes, exactly. That is also right answer. So here, third option is covalent bond is formed between two non-metal atoms. Yes, naturally. Always a covalent bond is formed between two non-metals. Suppose you take chlorine contains one electron, another chlorine one electron. So naturally mutual sharing takes place. Yes, exactly. So covalent bond is formed between two non-metals. This is also right answer. Then electrovalent bond is formed between metal and non-metal. Yes, exactly. Suppose you take Na plus as well as Cl minus. So like this NaCl is formed if metal is present, so naturally to form the respective products. So like that NaCl is formed. So here NaCl is a electrovalent bond. So here option is 1, 2, 3, 4 is the right answer. In this, here we are having 1, 2, 3, 4 options, the right answer. So thank you. Next, we'll go for next question. That is conditions for the formation of ionic bond. So first, what are the conditions? We'll go through that one by one. That is a small cation, large. What do you mean by what are the favorable conditions? Suppose here I'll give you, so cation and anion. Why ionic bond is nothing but one atom metal is ready to donate, then we can call it as a cation. And here anion means it is ready to accept. Ionic bond means one is donating and the one is accepting. Okay. So transfer of electrons. Suppose you take Na plus and Cl minus. So indirectly what happened? Na is donating one electron and Cl is attracting one electron. So to become what you call ion, so it is nothing but stable electronic configuration. So what are the favorable conditions for the formation of cation? Means suppose big atomic size. Suppose the size of the atom is very big, so we can remove electron easily. So big atomic size, favorable conditions for the formation of cation. Next, here small atomic size. Why small atomic size? Suppose small atomic size, they attract more. So that is why small atomic size form anion easily. Next one, low ionization potential. If low ionization potential means less energy is required to remove an electron. So that is also favorable condition. So here what happened? High what you call electron affinity. So that is the favorable conditions. What is electron affinity? So when an electron is added to an atom, certain amount of energy will be released. So that we can call it as what a electron affinity. So high electron affinity is required. Next, this one low electronegativity. So natural electronegativity means what? The tendency to attract the bonded electron pair towards itself. Then here what happened? High electronegativity means why it must be attract. So that is why high what electronegativity. These are the favorable conditions for the formation of cation and anion. So and here what about lattice energy? So more lattice energy is required. So as per our answers, small cation no must be big. Cation size must be big, very large. So yes, cation size is very high. So low ionization potential. Yes, naturally low ionization potential of cation and a high electron affinity of anion is the right answer. This is not less, less what you call lattice energy, not less lattice energy. It is more lattice energy is released, so that is why more is the right answer. So D option is given large cation as well as what small anion, less charge. Then if we talk about the left charge, suppose Na plus ion and Mg2 plus ions and what do you call Al3 plus ions. So among this, what Na plus is formed more easily, means less charge formed more easily compared to high charges. So that is why our option is B as well as D is the right answer. These are the conditions for the formation of ionic bond. This is nothing but a favorable conditions for the formation of cation, and the favorable conditions for the formation of anion is nothing but favorable conditions for the formation of ionic bond. Very good. Thank you. Then we'll go for next what do you call question. So identify the true statement regarding the covalent bond. So true statement means correct statement. Yes, we'll go to what do you mean by covalent bond? Covalent bond is nothing but sharing of electrons. Yes, exactly. So this is the sharing of one electron. This is very important. So not one electron. Electron pair. You have to write electron pair. That is very important. So here, if one electron means that is wrong answer. If you'll write a pair of electrons, pair. If you'll write pairs of electrons, then we can call it as what? We have to write this is a wrong answer. If it's a pair of electrons, that is right. So it is not right option. So this is non-directional. So covalent bond is non-direction. No, it will give you the direct. Suppose you take covalent bond, that is carbon dioxide. It will give you linear shape and it will give the direction. Yes, ionic bond is non-directional, but covalent bond is directional. Okay, good. Then the strength of the covalent bond depends on the overlapping. Yes, naturally, more overlapping, it's high strength to form a covalent bond. So next one, covalent bond may or may not be what you call polar. Yes, sometimes if they are having similar force of attraction, there is no that much what you call polar. What do you mean by polarity? Means the tendency, even though suppose you take HCl, it is a covalent bond, but here the bonded electron pair is nearer to chlorine atom and far away from hydrogen. Why? Because the tendency to lose, not lose, so just they are nearer. So it is partial negative. On other hand, it is a partial positive. Means the tendency to attract the bonded electron pair towards itself. That is called polarity. Means unequal sharing of bonded electron pair between the two atoms. Then we can call it as polar covalent bond. So may or may not be depends on electronegativity. If electronegativity is more, then go for what a polar. Polar means you have to indicate like this partial positive, partial negative. So suppose you take Cl. So here the bonded electron pair is exactly middle. But in HCl, what happened? It is not middle. So they are nearer to chlorine atom. That is, we can call it as polar. This is a polar compound. We have to say HCl is a polar compound. Thank you. So our right option is C as well as D is the right answer. Thank you. Next, we'll go for next question. So he's asking, identify the ionic compound of the compound. So here, which of the following is ionic among these? So here, metal is there, then here metal. So if carbon is there, I told already, if carbon present, so it forms only covalent bond. These two are covalent and these two are what ionic. So he asked about what which are the ionic compounds. Ionic means metal is present. So 100% metal means what is the character of metal? It is ready to donate electrons and non-metal is ready to attract. So like that bond is formed. Correct option is Bombay as well as Delhi is the right answers. Thank you. Then we'll go for next question. So, which among the following is not a property of coal? Not a property. So, losing electrons, no. Gaining of electrons, no. These are transfer of electrons. These three are properties, but he's asked not a property. That's very important. So, we have to not. So, sharing of electrons, yes. Sharing of electron pairs. So naturally, yes, exactly. That is a property of covalent. But he's asking about what not a property, not. So you have to go through that question carefully. So like that. So that is why two or more options. So it's the right answer. So next one, not isoelectronic. So here he used terminology not. You have to go to isoelectronic. What do you mean by isoelectronic? Iso means same number of electrons. Suppose CO contains how many electrons? First we'll see. That is carbon contains 6 electrons. Why it is equals to atomic number and 8. It is nothing but 14. So it contains 14 electrons, but there is no charge on carbon atom. CO, carbon monoxide. So now we'll go through that nitrogen. 2 into 7 here plus is there. Plus means what it is donating. So minus 1, 14 minus, so 13 electrons are present. Then what about this one? So 8 into 2 minus 1 plus 1 means you have to donating by donating 8 to the 16 minus 1 that is 15 electrons are present in O22 plus. Then what about Cn? 6 plus 7. Why carbon is 6 and nitrogen is 7 and here minus 1 means plus 1. Here you will get 7 plus 7 14 electrons. Then what about this oxygen? 2 into 8, then minus, here minus 1 is there means you have to put plus 1, then 16 plus 1, 17 electrons. Then what about this one? Here which is not isoelectronics, not. Use the terminology not. The not means answer is what do you call it? These three are the right answers. So A, B as well as D are the right answers. So not. So if you'll go to that only isoelectronic species, so same number of electrons at the time, you'll write C and minus. But he used the terminology not. Not means what? They are not similar. Similar number of what electrons. That is called isoelectronic species. So here, please, thank you for these questions. Please prepare what you call well for competitive type of examination. So thank you. So this is Dr. JMR. Please like, share, and subscribe. Thank you. This is Dr. JMR, JMR Chemistry. Thank you.